Okay, we'll pick up where we left off with number 70. So again, we graph this function f is equal to 9/5 c plus 32 using x for c and y for f on the graphing calculator. And we ended up with a graph that looks something like this. We set our window to go from -50 to +50 for Celsius with jumps of 10 degrees. And for degrees Fahrenheit, we went from -10 to 100 with jumps of 10 also. So for part B, it says, what is the slope of the line and what does it represent? Well, the slope of the line is the 9/5 that we multiply times c, and it represents the change in degrees Fahrenheit as degrees Celsius goes up. And what that means is that when Celsius increases by 1 degree, Fahrenheit is going to increase by 9/5 degrees. So degrees Fahrenheit will increase by 9/5 degrees Fahrenheit, or 1.8 degrees Fahrenheit. When C goes up by 1, F goes up by 1.8, and that's part B. Part C asks, what is the F-intercept of the line and what does it represent? Well, the F-intercept of the line is the F value, the degrees in degrees Fahrenheit, when the graph crosses the F-axis, or the Y-axis that we're looking at here. And what that means is that's the degrees Fahrenheit temperature when Celsius is 0. And that value is 32. So when degrees Celsius is 0, then degrees Fahrenheit is 32. All right, we'll continue with problem number 74. The equation W equals 3.51 L minus 192, expressing the relationship between the length L in feet and the expected weight in British tons of adult blue whales, was adopted in the late 1960s by the International Whaling Commission. What is the expected weight of an 80-foot blue whale? Well, if W is equal to 3.51 L minus 192, and if we let L be 80, well, the expected weight would be 88.8 British tons. That's for part A. For part B, we want to sketch the straight line that represents the equation. I'm going to go back to my graphing calculator. We'll go to y equals. This time I'll clear the other expression that's in there. And we want 3.51. We'll use x instead of L. 3.51x minus 192, enter. Now we still have to work on a window that will go with that. We just did an example of 80 feet and the result of 88 tons. So let's say that we have both x and y go from 0 to 100. So we go to window and we're going to go x min will be 0 to 100 by 10. The y min will be 0 to 100 also by 10. We hit graph and the graph looks something like this. I'll take a picture of that and post it on our workspace, and that looks something like this. And again, let's set up our scale. We go from 0 to 100 feet by tens, and for tons we go from 0 to 100 also by tens. Alright, now what that seems to imply is that, well, what that seems to imply from the picture anyway, is that when that the whale will weigh 0 tons when it is approximately 55 feet long. And I'm not sure if any whale that measures 50 to 60 feet in length will weigh 0 tons. So this probably is only valid as you get longer feet. And it may be that no whale is born at 50 feet long. They might be born larger than that to begin with. But that's what the graph will look like. So I include here the Y1 screen and the window screen so you can see how to construct that graph.